To test a null hypothesis of mu equals 100 versus an alternative hypothesis of mu does not equal 100, a simple random sample of size n equals 17 is obtained from a population that is known to be normally distributed. If x bar equals 104.9 and s equals 9.2, compute the test statistic. So, first of all, we notice that our sample size is less than 30, which normally would allow us to not be able to perform a hypothesis test, but our population is normally distributed. So we're good to go there. So our test statistic is x bar minus mu sub 0 divided by s over the square root of n. So we'll compute it by hand and then we'll do this in StatCrunch. So 104.9 minus 100 divided by 9.2 divided by the square root of 17. So parentheses 104.9 minus 100 divided by parentheses 9.2 divided by second x squared to get the square root, 17, close parenthesis, enter, and we get approximately 2.196. So let's do this in StatCrunch. So we're going to stat, tstats, one sample with summary. So our sample mean is 104.9, our sample standard deviation is 9.2, and our sample size is 17. And our null hypothesis is mu equals 100, and our alternative is mu does not equal 100. We're going to hit compute here. And our test statistic is, our 2.196. So now we want to test at the 0.01 level of significance, and we want to determine the critical values and draw the t-distribution that depicts the critical region. So we have a two-tailed test. So we know that we're going to have our critical region split here. So we need to come up with our degrees of freedom. And we know that this area is alpha divided by 2. Let's take alpha and divide it by 2. So 0.01 divided by 2 gives us 0.005. So that's the area in each of those. And then we know that in the middle of this t-distribution that we have a 0. So this one's positive and this one's negative. So kind of give us a starting point. And our sample size was 17, so our degrees of freedom is 16, so 1 minus. So we're going to come into StatCrunch and go to Stat, Calculators, T. So our degrees of freedom is 16, and we're going to do greater than, and then we know our area is 0.005, and we're looking for the value that sets that up. So we're going to hit compute. So 2.921. So we're going to round to 3 decimal places. So 2.921 and negative 2.921. So those two values are our critical values. Right? So another way to do this is to go to between and put in here, you're going to subtract, so you're going to do 1 minus alpha, right? So 1 minus alpha. Right? So So that's another way to do it. So this is 0.99. So that's the other way to do it, is do between. So I can go over here and type in 0.99 and hit compute, and you'll notice that I get those two values as well. So it's two different ways to do that. So now we want to know if the researcher will reject the null hypothesis. So I'm going to compare here. Where does this test statistic, where does that fall at in this region? So 2.196 is going to fall somewhere right here. So the test statistic doesn't fall in our critical region. Right? Right, so since the test statistic does not fall in the critical region, the researcher will not reject the null hypothesis. So remember, we reject when it falls in the critical region.